Welcome to Olympiad Primer. Today we will solve a very interesting equation, Diophantine equation, that is 21x plus 48y equal to 6 for all integer values. For all integer values. All integer values of x and y. We have already solved some Diophantine equations already before this class, and now it is very interesting that this type of Diophantine equation is to some extent new, because here if you observe this equation you will find out that coefficient of x and y, that is 21 and 48, have a common divisor, that is 3, isn't it? 21 and 48 have common divisor, that is 3. 3 is the common divisor, and not only 3 is the common divisor of 21 and 48, but also it is also a divisor of 6. Now at first we will divide 3. We will divide the equation by 3 and we will get the transforming equation like 7x plus 16y equal to 2. Now we can recognize this equation as equation number 1. So now see here, it is clear that 7x plus 16y equal to 2, this equation has the coefficients of x and y like 7 and 16. These two numbers is co-prime to each other because 7 and 16 have no common divisor. So now we can easily find out a value of x and y, because we have to search and find out at least one solution of this equation 7x plus 16y is equal to 2. So now we can easily find out a value of x and y, the integer value of x and y, for which 7x plus 16y equal to 2 must satisfy. So here easily we find that x, for x equal to minus 2 and y equal to 1, this equation 7x plus 16y equal to 2 must satisfy, because if we put the value of x and y for x equal to minus 2 and x equal to 1, we will get 7 into minus 2 plus 16 into 1 equal to also minus 14 plus 16 equal to 2. So it is equation number 2, we can put it, and now we can subtract equation number 2 from equation number 1, and we will get just x plus 2, because x minus 2. Here we will subtract the equation number 2 from the equation number 1, then the coefficient will be 7, the same, and if we take common 7, then we will clearly subtract and find out 7 into x plus 2 plus 16. If we take common 16, then we will get y minus 1, and here 2 minus 2, that is 0. So 7 into x plus 2 plus 16 into y minus 1 equal to 0, and this equation we can recognize it as 3, equation number 3. Now just observe this equation or relation, 7 into x plus 2 plus 16 into y minus 1 is equal to 0. Here the equation has no constant term in the right side. Here right side is 0. So now clearly we will understand that here this relation will be possible when x plus 2 must be divisible by 16. The same way y minus 1 must be divisible by 7. X plus 2 must be divisible by 16 and y minus 1 must be divisible by 7, isn't it? Then the equation 7 into x plus 2 plus 16 into y minus 1 equal to 0 will satisfy. And also we will suppose the value of x plus 2 equal to the common like 16k for any k is any arbitrary integer, like 0 plus minus 1 plus minus 2 plus minus 3. So like this, and y minus 1 x plus 2 equal to 16k, and likely y minus 1 equal to minus 7k, because here 7 into x plus 2 plus 16 to y minus 1 equal to 0. So if we just assume the value x plus 2 equal to 16k and y minus 1 equal to 7k, then for these two integer value of x plus 2 and y minus 1, the equation 7 into x plus 2 plus 16 into y minus 1, the equation number 3, must be satisfied with these two value of x plus 2 and y minus 1. So from this we also get x equal to minus 2 plus 16k, and here also we will get from the y minus 1 equal to minus 7k, we will get y equal to 1 minus 7k, isn't it? So these two value of x and y will satisfy the equation 7 into x plus 2 plus 16 into y minus 1 equal to 0, as well as satisfy the equation 21x plus 48y equal to 6, the given equation. So this is the common general solution, clearly common general solution, and k is any arbitrary integer. So this was the today's class and today's solution of the Diophantine equation. So I think all of you have understood well. So thank you all.